Hey, Miss Miklos here with another exciting quadratic lecture. And today we're talking about modeling word problems. So we're going to learn how we can use quadratic functions to model real-life situations and how knowing how to get a quadratic equation into vertex form can be helpful for us. So just kind of to review, we've previously learned that a vertex is either a maximum value or a minimum value. So here's an example where our vertex would be a maximum because it's decreasing on both sides. Here our vertex is a minimum value because it's increasing on both sides. And often with our quadratic word problems, it will ask us to either maximize something or minimize something. So what we're trying to find there is this vertex value, and it might be the x value, might be the y value. So we need to pay attention to what the problem is telling us to do. We have previously learned how to solve for the vertex by completing the square. Sometimes when we don't care about graphing and all the characteristics, an easier way to find the vertex, our x value is the opposite of b over 2a, and then whatever that x value is, we can substitute in to find the y value. Okay, so this is just an alternate method of finding the vertex. So let's practice with this equation, f of x equals 3x squared minus 5x plus 7. So to find x, I'm going to do the opposite of b over 2a. So I would do the opposite of negative 5 over 2 times 3, or 5 over 6. So I know that is the x value of my vertex. Now to find the y value of the vertex, I'm going to have to do 3 times 5 over 6 squared minus 5 over 5 over 6, 5 times 5 over 6 plus 7. I know this looks like a lot of fun here. So I'm going to do 3 times 25 over 36 minus 25 over 6 plus 7. So I'm going to go ahead, and I know that 3 goes into 36 12 times, so this is really like 25 over 12. I'm foreseeing I need a common denominator, so I'm going to make 25 over 6 into 50 twelfths plus 84 over 12. We love fractions, so we know that we just need to keep our denominator the same and combine our numerators. So I have negative 25 plus 84, which is 59. So that means that our vertex is 5/6, 59 twelfths. And so we know this is the x value of our vertex, and this is the y value of our vertex. So that is just an alternate method to find the vertex of a quadratic function. So our problems tonight are going to look like this, and we're starting off with an easier one. It says find two real numbers with a sum of 14 and a product as great as possible. And we're so used now to go, okay, x equals y equals, but we know our equations, this chapter, have really dealt with things that are quadratic. So I know somehow I need to have an x squared in there. So I'm going to say x is equal to our first number. And if I know that the sum is 14, I can say that 14 minus x is my second number. Okay, so what we've kind of done away with that y value, and we've figured out that it's 14 minus x already. So I'm going to say f of x equals, since it's talking about a product, I know product means that I'm multiplying things together. So I'm going to say x times 14 minus x. And since we want a great as possible, that's telling me we want to maximize x. So I want my point up here. So I'm going to go ahead and do f of x equals 14x minus x squared. So f of x equals negative x squared plus 14x. And even though we don't need to graph this, I know this negative means that our parabola is going down, which tells me I'm on the right track because I know I need to get a maximum value. So what I'm going to do here, I'm going to just find the x value of the vertex because I know the x value is going to be the number, or I should say the first number that's going to give me the greatest product possible. So I'm going to do the opposite of b over 2a. So I have the opposite of 14 over 2 times -1, which becomes 7. To find our second number, I'm going to do 14 minus 7, which is also 7. So I get 7 and 7 as my two answers. And what this is telling me, these are the two numbers that add up to be 14 that have the greatest area. And something important for us to think about is, what does f of x represent? Okay, because we're saying x is the first number, 14 minus x is the second number. F of x represents the area. So if this problem went a step further, which it doesn't, but if it asked me what is the maximum area, I would need to take this 7 here and substitute it back in to find the y value. Okay, because I know the y value here is our area. So it's a little bit of a different way of thinking in terms of word problems because we're not solving in the normal sense. We are finding a value of the vertex. So let's just go through one more example of this. A pin is to be built along the wall from 140 meters of fencing. Find the greatest possible area. And I actually forgot to write in here that this should be a rectangular pin. So I'm going to start here by kind of drawing this out. There's the wall. And I'm going to say this is the length. I don't know if it's a rectangle. I know that the opposite side is also going to be x. Now with my picture, I know that this length is going to be whatever is left over. So I'm going to take 140 and subtract 2x because 140 is going to be the total amount of the fencing. And I'm subtracting 2x because I have this x and I have this x. So now I'm going to say f of x, because it's talking about area, so I'm going to want to multiply, equals x times 140 minus 2x. And if we take a look at this, I wrote this one on purpose because it's not asking me what are the dimensions of the fence. It's asking me what is the greatest possible area. So we know f of x in this case represents the greatest possible area. So what I'm going to have to do is find the x value of my vertex, then substitute that back into our function to find out what the corresponding y value should be. So in this case, I'm going to go ahead and make this 140x minus 2x squared. And I'm going to go ahead and rewrite it in the order that we like. So I know that x is equal to the opposite of b divided by 2a. So I have negative 140 divided by negative 4. And I believe that goes in 35 times. Yeah. So what this tells me is that this should be 35 meters to represent the greatest possible area. However, that's not what the question's asking. It's asking me then to figure out, well, what is the area when x is 35? So I'm going to do 35 times 140 minus 2 times 35. So I end up getting 35 equals 35 times 70, which is 2,450 meters squared. So just kind of to remind us what we did here, the first thing we did was find the maximum x value by doing the opposite of b divided by 2a. And then once we found that value, we substituted it back into our equation to figure out the maximum area. Okay, so you guys are doing a walkthrough for this particular problem, I would definitely suggest working through most of the suggested problems just to get the hang of what we're doing. The answer key is also online, and that can be helpful. On this walkthrough, I'm definitely expecting to see a lot of explanation from you as to how we got that particular problem.